This lesson intends to consolidate our knowledge of trig of right angle triangles. You've already had a look at finding an angle. In this lesson I want to go back over it in much more detail and also take it into more interesting areas with some more interesting problems to solve, and you can see what typical GCSE questions look like. So when would we use trigonometry? Well, we've got to have a right angle triangle for starters. It won't work in this method of trigonometry, will not work in any other type of triangle. And we use trig when we're involving two side lengths and an angle. So the side lengths here that are involved are the 4 and the x, and the angle is 30. So my 4 is opposite to my 30. My x is adjacent to 30. So the ratio used is a tan ratio because we have an opposite side and an adjacent side. So always remember SOHCAHTOA. Whenever you do trigonometry, write SOHCAHTOA at the top of the page. So if we look at our triangle here, we know that we've got to use the tan ratio, and the tan of 30 is the opposite over the adjacent. So if I put my numbers in, the tan of 30 is 4 over x. So if I times both sides by x, I get x tan 30 is 4. So 4 divided by tan 30 must be what x is, which is 4 root 3 or 6.93. I don't mind if you leave it in surd form or you go to a decimal. Either will be fine for me. Sometimes you will not get a surd form because there isn't a neat and tidy surd that it will turn into. So, what happens when we don't know the angle? Well, we're going to use exactly the same process as we used to finding the sides, and we're going to adapt it a little bit at the end. So the first thing we did was decide what the names of the sides were, determining which sides are the hypotenuse, adjacent or opposite. So my 3 is the opposite, my 5 is the hypotenuse. Then I work out which trigonometric function I want to need. So as I've used the opposite and the hypotenuse, I'm going to use the sine function. So the sine of the angle A is 3 over 5. So we need to be able to ask the calculator, if I've got 3 over 5, what is the angle? That's what we're going to do. So to do this, at this stage I say rearrange to find the unknown, but actually what we're going to do, to get A on its own, we're going to find the inverse of the sine, the opposite, and that cancels out the sine. So I'm going to find the inverse of the sine on both sides, which will leave me with A on one side and the inverse sine of 3 over 5, i.e. the calculator will look at 3 over 5 and say, hang on, that angle's 36.9. You don't need to worry how it does it, it's quite clever, and the maths for that is taught at A level. Well, I say taught at A level, could be taught at A level if you were interested. It's not actually taught as a separate topic. So the picture here shows you a video that I've set up on the Maths CNS channel, and it's really how to use your calculator, just showing you which buttons to press. So if you want to have a look at, if you want to stop the video now and go and find that, you can do. If you want to carry on, you can do. If you can work out how to use the calculator without that video, it's perfectly fine. So let's test your understanding. If you don't want to stop the video now, you don't have to, but you can stop it now and have a go at this. But I'm going to talk us through this actual problem. So it's from a GCSE question. This GCSE question would be grade 5. The next one would probably be grade 6 or 7. So PQR is a right angle triangle. PR is 12 centimetres long. QR is 4.5 centimetres. Angle PRQ is 90 degrees. Work out the value of x. Give your answer correct to one decimal place. So step 1. Determine which sides are the hypotenuse, adjacent or opposite. So I've got an opposite and adjacent. So if I'm going to work out my trig function, I can write down SOHCAHTOA, and I notice that I've got an opposite and adjacent, which means I need the TOA part, which is the tan. So the tan of the angle is 4.5 over 12. So if I take tan to the -1, the opposite, and I get my calculator to do the opposite for me, I get 20.6 degrees. This one is a slightly harder question, and because it's got two techniques you can already do, although one of the techniques, Pythagoras, is grade 4, and the other technique, trigonometry, is grade 5, putting them together makes this question grade 6, heading towards grade 7. So, the diagram shows a triangle ABC. D is the point on AB, such that CD is perpendicular to AB. So CD is the line that's going downwards on the vertical. You're giving the various side lengths, and we want to calculate the angle ABC. And I put a little arrow to show you where the angle is. So it's the angle B, because it's the middle one of the three letters. So let's have a look at the right angle triangle, and you'll notice I've got a right angle triangle, I've got an angle, I've got a side. I do not have enough information to find anything at the moment. So I need 3 bits of information for trig. There's 2 unknowns, or 2 knowns and 1 unknowns, but I've got 2 unknowns and 1 known. That's not going to work. So I'm going to look at the next door triangle, and I notice that side CD and 8.3 and 4.7 form a right angle triangle. Ooh, I can use Pythagoras to find CD. So I can use Pythagoras, and if I do that, if I square 8.3 and take away 4.7 squared, I get 6.84105, which is rather long. So I've got this. I've now got 2 sides and an unknown angle. I can use trig. Hooray! So let's go back, identify the sides, opposite and adjacent. If I've got the opposite and adjacent, I'm going to use SOHCAHTOA. I need the tan. Tan of B is opposite over adjacent. Tan B is 6.84105 divided by 7.5. So the angle ABC equals the opposite of the tangent. So I put my ratio function in, my fraction to find the ratio. I press Shift Tan, and that will give me 42.4, because my calculator stores both the angle and the ratio that made up the angle. So if you've got the ratio, you need to find the angle. So we've got 2 pages of exercises. These are supplied on a separate PDF. You will notice the first page I expect everyone to do. The second page, the only question on the second page I expect everyone to have a go at is question 4. Question 5 and 6 are GCSE grade questions. They require a bit of thought. Have a go at them. They're not straightforward, and certainly your workings wouldn't fit into that box. You're going to need to do your workings on a separate page. And then the pirate question, for those who feel like walking the plank and landing splat in the ocean, is here. Please do not do the pirate option if you don't feel like it. In fact, ignore the GCSE questions if you don't feel like it. They're there for those who can work fast and can do them, and can prove that at year 9 they can do some GCSE questions. Okay, off you go.